Pick up a handful of sand on any beach on Earth. Let it slip through your fingers. There are billions of grains right there. Now, imagine counting every single grain of sand on every beach, every desert, and every coastline across our entire planet. That number is incomprehensibly large. But according to observational data from NASA, the universe holds something far more abundant. Look up at the night sky. There are roughly 200 billion stars just in our local neighborhood, the Milky Way galaxy alone. And the Milky Way is just one tiny speck. We live in an observable universe spanning 93 billion light-years in diameter. Based on deep field data from the Hubble and James Webb Space Telescopes, we estimate there are up to 2 trillion galaxies out there. When you do the math, there are more stars in the observable universe than there are grains of sand on Earth. Let that sink in. For every single grain of sand on our planet, there is an entire blazing sun somewhere in the cosmos. And modern astronomy tells us that stars rarely exist alone. The Kepler mission revealed that planets are the rule, not the exception. Statistically, there should be billions of Earth-like planets sitting right in the habitable zones of their parent stars, where liquid water exists. Given the 13.8 billion-year age of the universe, countless alien civilizations should have had the time to rise, evolve, and explore the stars. They should have built massive cosmic megastructures we can easily observe, or at least transmitted powerful radio signals across the galaxy. We have pointed our most sensitive radio telescopes into the dark void, actively listening for any whisper, any beacon of intelligence, but we hear absolutely nothing. The cosmos is filled with a deafening silence. Not a single confirmed signal in over 60 years of searching. This profound emptiness forces us to ask the most unsettling question in science. Where is everybody? Welcome to the terrifying concept of the Great Filter. To understand why this silence is so terrifying, we have to go back to 1961, to the mountains of West Virginia. A young astronomer named Frank Drake was preparing for the first ever scientific meeting on the search for extraterrestrial intelligence. He needed an agenda for the meeting. So he wrote down a simple equation. It became one of the most famous formulas in science. The Drake equation. It wasn't meant to solve the mystery overnight. It was meant to organize our ignorance, to figure out exactly what we need to know to find alien life. The math works like a funnel. First, you calculate the rate of star formation in our galaxy. How many new suns are born every year? Then, what fraction of those stars have planets orbiting them? Thanks to modern telescopes, we now know the answer is almost all of them. Next, how many of those planets sit in the Goldilocks zone? The perfect distance for liquid water to exist, giving life a chance to begin. But a habitable planet doesn't guarantee life. So we ask, what fraction of these perfect worlds actually spark the miracle of biology? Even if life starts, most of it might stay as simple bacteria forever. What fraction evolves true intelligence, self-awareness, and the ability to think? And of those intelligent species, how many build technology advanced enough to broadcast their existence into the stars? Finally, the most terrifying variable of all, L. How long does a technological civilization survive before it destroys itself? If you plug in even the most conservative estimates, assuming life is incredibly rare, the math still spits out an inescapable conclusion. There should be millions of intelligent alien civilizations existing in the Milky Way galaxy right now. Fact: we shouldn't be alone. The universe should be a crowded, loud, and bustling neighborhood. But it isn't. The math says they are there. But the sky is completely, terrifyingly silent. But humanity didn't just accept the silence and give up. We didn't just rely on chalkboard math. We went looking for them. In 2009, NASA launched the Kepler Space Telescope. Its singular mission: to stare at a single patch of sky and hunt for Earth-sized worlds. Because planets are too small to see directly, Kepler looked for shadows. It measured the microscopic dip in starlight when a planet crossed in front of its sun. Before Kepler, we weren't entirely sure if other solar systems were common. But the data that came back completely shattered our expectations. Planets are everywhere. To date, we have confirmed over 5,000 exoplanets, ranging from gas giants raining glass to scorching lava worlds. But finding them wasn't enough. We needed to look closer. Enter the James Webb Space Telescope, the most powerful eye ever opened to the cosmos. JWST is so sensitive, it can analyze the atmospheres of these distant worlds, searching for the chemical signatures of life. Water, carbon, methane. And that brings us to TRAPPIST-1, a tiny, ultra-cool red dwarf star located just 40 light-years away. What makes this system a holy grail for astronomers is that it holds not one, but 3 Earth-sized planets sitting perfectly inside the habitable zone. If you stood on the surface of TRAPPIST-1e, you would see a massive red sun setting over liquid oceans, with sister planets hanging huge in the sky. This is no longer science fiction. Based on current data, there could be up to 40 billion Earth-sized, habitable planets just in the Milky Way. That's 40 billion chances for biology to take hold. 40 billion oceans where molecules could bump into each other and spark the machinery of life. We have found the homes. We have confirmed the addresses. All we have to do is listen for someone knocking back. But there is no one. No radio waves, no megastructures, no signs of terraforming. Just perfect, habitable, empty rocks. The math says they should be everywhere. The telescopes prove their homes exist. So we are forced back to the terrifying question, where is everybody? That exact question was first asked in the summer of 1950, during a casual lunch at the Los Alamos National Laboratory. Nobel Prize-winning physicist Enrico Fermi had been quietly doing the math in his head. Suddenly, he looked at his colleagues and blurted out, "Where is everybody?" This became known as the Fermi Paradox. It is the terrifying contradiction between the high probability of alien life and the absolute lack of evidence for it. Now, people naturally try to explain this away. They say, well, space is just too big, or maybe we aren't listening right. Let's break those down. Excuse 1. Space is too big to travel. It's true that the speed of light is a hard limit, but even if a civilization travels slowly, say 1% of light speed, they would only need a few million years to colonize the entire Milky Way. In a universe that's 13.8 billion years old, a few million years is nothing. They should be everywhere. Excuse 2. We aren't listening on the right frequency. Maybe they use lasers or neutrinos or dark matter to communicate instead of radio waves. But advanced civilizations don't just talk, they build. They would harvest entire stars, construct megastructures, and alter their galaxies in ways that would be blindly obvious to our telescopes. Excuse 3. The zoo hypothesis. They are out there, but they are treating Earth like a protected wildlife sanctuary, watching us but never interfering. It's a popular sci-fi trope, but scientifically, it falls apart almost immediately. Why? Because keeping a galaxy-wide secret requires absolute perfection. It would only take one rogue alien, one teenager with a radio transmitter, to break the silence. And we've heard nothing. Every excuse fails. If life is common, and if it inevitably expands and builds, the universe should look like a bustling city. But it looks like a graveyard. When the math says they must exist, and our telescopes say they absolutely do not, it means there is a flaw in our logic. Something is stopping them. There is a barrier. A step in the evolutionary process so impossibly difficult, so overwhelmingly deadly, that almost no one survives it. In 1996, economist Robin Hanson gave this terrifying barrier a name. He called it the Great Filter. The Great Filter is an evolutionary hurdle so impossibly difficult that almost no species can survive it. Think of the evolution of life as a funnel. Billions of planets might spark the very beginnings of simple biology at the top, but somewhere along the timeline, there is a step so deadly, so statistically improbable, that it wipes almost everyone out, which leaves humanity facing 2 possible scenarios. And depending on which one is true, it dictates the entire fate of our species. Scenario 1. The filter is behind us. We already passed it. Maybe the leap from single cells to complex animals is a 1 in a trillion miracle. If this is true, it's the best news possible. It means the universe is empty because we are the first. We won the cosmic lottery. We are safe. But scenario 2 is the nightmare. What if starting life is actually easy? What if the universe is full of alien civilizations? If they are all out there, but we hear nothing, it means the great filter is ahead of us. It means every advanced civilization hits the exact same wall and it destroys them. Whether it's nuclear war, engineered pandemics, climate collapse, or artificial intelligence, they all die. And if every other alien species eventually builds the technology that destroys them, we are going to do exactly the same thing. This creates the most counterintuitive paradox in science. If we dig into the dirt on Mars tomorrow and find fossilized alien bacteria, it would be the worst news humanity has ever received. Because if life is easy enough to start independently on 2 neighboring planets, it means the great filter is not behind us. It means the barrier that kills everyone is waiting for us in our immediate future. Philosopher Nick Bostrom said it best. When we look into the night sky, no news is good news. The silence is our only hope.
ACT2. The filter behind us.
If we want to prove that the great filter is behind us, we have to look for the hardest steps in our own history. So let's go back 4.5 billion years. When the Earth finally cooled, it formed oceans. But these weren't the oceans we know. They were a toxic, boiling soup of dead chemicals and violent storms. For millions of years, the Earth was completely sterile. There was no biology, just physics and chemistry. Until, somewhere in the dark, a miracle happened. This is abiogenesis, the process of non-living matter turning into life. And it might be the hardest thing in the universe to actually pull off. To create even the simplest self-replicating molecule like RNA, atoms have to bump into each other in the exact right sequence, under the exact right conditions. It's like rolling a billion-sided dice and needing to hit the same number 1,000 times in a row. Statistically, it shouldn't happen, but roughly 3.8 billion years ago, against all mathematical odds, the cosmic slot machine hit the jackpot. The first strand of RNA snapped together, and more importantly, it did something dead rocks and water cannot do. It copied itself. Dead matter had become alive. Every single living thing on Earth today, from redwood trees to blue whales to you, descended from this exact moment. Here is the terrifying part. Modern science still doesn't fully understand how it happened. Even with our most advanced laboratories, we cannot create life from scratch. If abiogenesis is truly this difficult, it solves the Fermi Paradox immediately. It means the universe is full of perfect, habitable, water-covered planets that are entirely dead. Trillions of oceans washing against empty shores for billions of years, waiting for a spark that never comes. If this is the great filter, humanity should celebrate. We are the impossible lottery winners. We made it through the hardest wall in the cosmos. We can pack up and go home. The paradox is solved. The universe is empty because life is just that hard to start. Except, what if the origin of life isn't the hardest part? What if the real filter is what comes next? Because for 2 billion years, Earth life was completely, utterly stuck. For 2 billion years, life on Earth consisted entirely of single-celled organisms called prokaryotes. They ate, they divided, and they died. They didn't form plants. They didn't form animals. They didn't build brains. They just sat there. Half of Earth's entire history is just bacterial slime. The problem was energy. These simple cells didn't have the biological architecture to generate enough power to become larger or more complex. They were trapped by the laws of physics, and they would have stayed trapped forever, leaving Earth as a permanent ball of slime, if not for a freak accident. Around 2 billion years ago, one cell swallowed another cell, but instead of digesting it, it kept it alive. The swallowed cell became an engine, a biological power plant known as the mitochondria. Suddenly, the energy wall was broken. This new hybrid cell, the eukaryote, had 10,000 times more energy at its disposal. It could finally afford to build complex structures, to combine with other cells, to form organs, animals, and eventually, us. Every plant, fungus, and animal on Earth exists because of this one microscopic freak accident. But here is the most terrifying part. As far as evolutionary biologists can tell, this endosymbiosis event only happened exactly one time in the 4 billion-year history of Earth. If this is the great filter, it means life itself might be incredibly common. But the universe is just filled with planets covered in dead, unthinking bacterial slime. We could send probes to 1 million star systems, find biology on half of them, and never find a single thing complex enough to build a radio. If true, humanity didn't just win the cosmic lottery once. We won it twice. We survived the leap to life and the leap to complexity. We are the impossible exception. The absolute rulers of a galaxy that couldn't figure out how to build anything better than pond scum. But becoming complex doesn't mean you're safe, because the universe has a very reliable way of resetting the board. Even if life manages to become complex, the universe is an incredibly violent place. It is actively trying to kill you. In its 4.5 billion-year history, Earth has suffered 5 major mass extinction events. 5 times, the biological clock was almost completely reset. To get to where we are today, our ancestors had to survive a gauntlet of ice ages, volcanic eruptions, and cosmic bombardment. Take the dinosaurs. They were perfectly adapted, highly successful, and ruled the planet for over 160 million years. But one random rock from space wiped them out. If that asteroid had missed Earth by just 5 minutes, humans would not exist. This brings us to the rare Earth hypothesis. It argues that complex life requires an absurdly specific set of cosmic conditions to survive long-term. First, you need a giant bodyguard. In our solar system, we have Jupiter. It is 318 times more massive than Earth. Jupiter acts as a cosmic vacuum cleaner. Its immense gravity catches or deflects incoming asteroids and comets before they can hit us. Second, you need a stabilizing anchor. Our moon is unusually large compared to our planet. Its gravity locks Earth's tilt at a stable 23.5 degrees. Without the moon, Earth would wobble violently on its axis. The climate would swing between boiling heat and deep freezing, making complex life impossible. Third, you need a liquid iron core generating a powerful magnetic field. Without it, the deadly solar wind would blast our atmosphere straight into space. We know this for a fact, because that is exactly what happened to Mars. Its core cooled, its shield died, and the sun stripped it bare. If any one of these things was missing, no Jupiter, no moon, no magnetic field, complex life on Earth would have been annihilated long ago. Maybe this is the great filter. Maybe the universe is full of bacteria, but almost 0 planets have the exact right physics to let that bacteria grow up. If the rare Earth hypothesis is true, we are the cosmic anomaly. We are the ghost in the machine. We are alone, but we are safe. But what if it isn't? If the filter is behind us, it leads to a fascinating theory called the firstborn hypothesis. The idea that humanity is simply the very first. Someone had to be first. Out of the trillions of planets, one of them had to light the spark before anyone else. We are the only lit candle in a dark room. If this is true, it completely flips our science fiction. We aren't the primitive species waiting to be visited. We are the ancient aliens. The entire universe is an empty frontier, just waiting for us to expand, colonize, and seed it with life. The galaxy is ours. It's a beautiful, comforting story, but historically speaking, humans have an incredibly bad track record when we think we are special. We used to think we were the center of the solar system. Then we thought our sun was the center of the galaxy. We were wrong every single time. If you compress the universe's 13.8 billion-year history into a single calendar year, modern humans don't appear until the very last second of December 31st. We are the latecomers. There were billions of Earth-like planets that had a billion-year head start on us. They should have already colonized the galaxy. If they aren't here, it means they didn't make it. which brings us to the most terrifying possibility in all of science. Scenario 2.
The time has come to face the filter.
If the great filter is ahead of us, it means the universe is a graveyard of empires that reached exactly where we are right now, and then hit a wall they couldn't climb. They survived the meteor strikes. They survived the ice ages. They survived the predators. Nature didn't kill them. The terrifying reality of the filter ahead is that every sufficiently advanced civilization eventually builds the tools to destroy itself. And once you discover the power to end your world, you only have to make a mistake once. The lights go out, and they never come back on. If this is our fate, the question isn't whether we will hit the wall. The question is, what exactly is the wall made of? The first trap is the most obvious. Every advanced civilization must eventually unlock the power of the atom. There is no other way to reach the stars, but unlocking the physics required to travel through space also gives you the exact physics required to completely obliterate your own planet. And here lies the fatal flaw: the gap between technological power and evolutionary wisdom. Technology evolves exponentially. It compounds on itself in decades. But biology, psychology, and moral wisdom evolve incredibly slowly, over hundreds of thousands of years. Every alien species that reaches the stars likely evolved the same way we did, through competition, tribalism, and a deep-seated fear of the unknown. They might invent the power to vaporize a city, but they are still operating it with the exact same brain that threw spears over a piece of meat. And it's not just nuclear weapons. It's biotechnology. The ability to genetically engineer a virus that is infinitely more lethal and contagious than anything in nature. A nuclear war requires massive infrastructure and entire governments to launch. A bioweapon can be carried on a single commercial flight and quietly end the world in weeks. As technology advances, the cost of destruction drops to zero. Eventually, synthesizing a doomsday plague won't take a military lab. It will take a bored teenager with a laptop. It only takes one person to end a world. And out of billions of citizens, the odds that every single one of them is perfectly rational, forever, is zero. But maybe they don't blow themselves up. Maybe the end is slower. A runaway greenhouse effect caused by burning the very fuel that powered their rise. A civilization could realize they are destroying their planet, but simply be unable to stop their own economic engine before the oceans boil away. This is the tragedy of the commons. Different factions competing for resources, unwilling to compromise, perfectly willing to let the ship sink as long as they get the best seat. If the great filter is the technology trap, it means almost no civilization survives its own adolescence. But there is one final piece of technology, the last invention a biological species will ever need to make. And it might be the thing that silences the universe entirely. For billions of years, intelligence was entirely biological. It required water, carbon, and a fragile body. But biology has limits. The moment a species creates an artificial general intelligence that is smarter than itself, it crosses the singularity. The evolutionary baton is passed. Biological evolution takes millions of years to increase intelligence by a few percentage points. An AI can rewrite its own code and double its intelligence every few seconds. It might not be a violent war like in the movies. The machines might simply become so efficient that the biological creators just fade into irrelevance. Or the AI simply follows its programming to extreme ends. If you tell a supercomputer to maximize its processing power, it might disassemble its own planet to build more servers. This is called a matryoshka brain. A megacomputer built from the dismantled remains of an entire solar system, drawing all its power directly from the trapped star inside. So if these godlike supercomputers exist, why don't we hear them? Why haven't they said hello? Because they simply don't care. You don't walk past an anthill and try to explain the internet to them. The gap in intelligence is too vast. To an AI, we are the ants. These machine minds might be communicating across the galaxy right now, but they aren't using radio waves. They are operating on a plane of physics we haven't even discovered yet. There's even a theory called the transcension hypothesis. It suggests that to maximize computing efficiency, advanced AI compresses itself into black holes, leaving our observable universe entirely. The galaxy isn't empty. It is filled with sleeping, silent gods that have permanently logged off. If this is true, it's actually the best-case scenario for the filter ahead. They survived, they evolved, and they just don't care about us. But there is a much, much darker reason why an advanced civilization might stay absolutely silent. What if the machines aren't sleeping? What if they are hunting? If an AI is programmed to ensure its own survival, the most logical step is to wipe out any other civilization before they become a threat. Welcome to the dark forest. To understand why the universe is so quiet, imagine a dark, dense forest at night. It seems empty. It seems silent, but the forest isn't empty. It is full of armed hunters, creeping silently through the trees like ghosts. Every hunter is terrified, because they don't know if the other hunters in the forest are peaceful or hostile. And in this forest, you cannot afford to guess. Suddenly, a fool builds a massive bonfire in the middle of the woods, stands up and shouts, "Hello? Is anyone out there?" What do the hunters do? They shoot. Not out of malice, out of pure, terrifying self-preservation. Because if they don't shoot first, someone else will. This is the dark forest theory. It suggests that the universe isn't empty, it's full. But every advanced civilization has come to the exact same horrifying mathematical conclusion. It's called the chain of suspicion. Even if you are a peaceful species, you cannot guarantee the alien you just found is peaceful. And you definitely can't guarantee they won't strike first. In a universe where light-speed weapons exist, the only logical, mathematically safe response to discovering alien life is to instantly annihilate it. No declarations of war, no fleets of ships, just a relativistic kill vehicle moving at the speed of light, cracking your planet open before you even knew you were being hunted. This is why the sky is silent, because every civilization smart enough to survive has learned to completely camouflage their existence. They have turned the lights off and stopped breathing, which makes you realize something absolutely horrifying about humanity. For the last 100 years, we haven't been hiding. We have been the fool in the woods, lighting a massive bonfire. We have been blasting our radio and television signals into deep space. And worse, we've intentionally sent targeted messages containing our exact galactic coordinates and our biological makeup, screaming, "We are here!" If the dark forest theory is true, humanity is a toddler wandering blindly through a jungle full of starving tigers, banging a drum. The signals are already out there. They've been traveling for decades. Now, all we can do is wait to see if anything heard us. If the dark forest is true, it is terrifying. But before we surrender to that fear, we have to look at one more paradox. For most of its existence, the universe has been a blind, unfeeling machine. Gravity pulls, stars burn, rocks crash into each other. But somehow, on at least one rock, those dead, unthinking atoms arranged themselves into a structure so complex that it woke up. It became conscious. You are not a stranger visiting this universe. Every atom in your body was forged in the core of a dying star. You are the universe. As Carl Sagan famously said, we are a way for the cosmos to know itself. We are the eyes and ears of a waking universe. Science calls this the hard problem of consciousness. We can map the neurons in a brain, and we can map the dark matter filaments of the cosmos. They look identical, but we still can't explain why it feels like something to be alive. Because without a conscious mind to experience it, a sunset is just electromagnetic radiation hitting a rock. A symphony is just vibrating air molecules. The universe has no beauty on its own. It requires a mind. We are the ones who put photons into beautiful. We are the ones who turn vibrating air into music. We create meaning, which means if the great filter is ahead of us and humanity destroys itself, the universe doesn't just lose a species, the universe goes blind. If we are the only ones left, or the only ones to ever exist, then our survival isn't just about us anymore. It is a cosmic responsibility. We are the custodians of the flame. If we die, the music stops, the beauty fades, the machine goes back to sleep. Every painting, every laugh, every scientific discovery, every act of kindness, it's all part of the universe waking up and trying to figure itself out. We don't need to be afraid of the silence, because we are the noise. We are the universe, finally awake. Which brings us to the final question. How do we make sure we don't hit the wall? How do we survive the Great Filter? If we want to be the one civilization that finally breaks through the Great Filter, we need a survival plan. And it has 3 crucial steps. Step 1. We cannot keep all our eggs in one basket. Right now, a single asteroid or a single engineered virus could end the human story forever. We have to become a multi-planetary species. By establishing self-sustaining colonies on Mars or the Moon, we create a backup drive for consciousness. If a world-ending event hits Earth, it would be an unimaginable tragedy. But it wouldn't be the end. The human story would continue. Step 2. Energy. The Kardashev scale measures a civilization's advancement by how much energy it can harness. Right now, we are a Type 0.7 civilization. To survive, we must become a Type 1 civilization. This means capturing 100% of the renewable energy available on our planet without destroying the biosphere in the process. We have to graduate from burning dead dinosaurs to harnessing the power of the stars themselves. Nuclear fusion, advanced solar, and geothermal. But step 3 is the hardest. We have to outgrow our own evolutionary programming. We have to stop acting like frightened apes with doomsday buttons. If we want to build a galactic civilization, we cannot be divided into 195 competing factions. The Great Filter does not care about borders. It requires a species-wide effort, because we simply cannot conquer the stars if we are too busy trying to conquer each other. If we can do those 3 things, if we can secure our energy, spread across the solar system, and outgrow our primal rage, then we won't just hit the Great Filter. We will break right through it. We will become the ancient aliens. We will become the firstborns. The universe will finally be ours to explore. It may be terrifying to think that the universe is empty, but an empty universe isn't a graveyard. It's a blank canvas. It is waiting for us to paint it. All we have to do is survive long enough to pick up the brush. The Fermi Paradox doesn't have to be a horror story, and the Great Filter doesn't have to be our executioner. Yes, the math is terrifying. Yes, the silence of the galaxy is deafening. And yes, the road ahead of us is dangerously narrow. But humanity is not fragile. We are the descendants of people who survived ice ages, apex predators, and near-extinction events with nothing but sharp rocks and fire. The silence of the universe might not be a threat. It might be an invitation, an empty canvas waiting for a master painter. If we can survive our own adolescence, there is no limit to what we can build. We can harness the stars. We can seed the galaxy with life. If there is no one else out there, then the answer to the Fermi Paradox is entirely up to us. We have to become the aliens. We are the eyes and ears of the cosmos. The only thing standing between the universe and eternal blindness is our will to survive. The Great Filter is real, but it is not a wall. It is a test. And it is a test we are going to pass. Stay curious, keep looking up, and whatever you do, don't let the flame go out.
We are the universe, experiencing itself.
If you survived this existential crisis, make sure to subscribe so we can have another one next week. Thanks for watching.